This is a podcast that looks at bond energies, and specifically we're going to concentrate here on covalent bonds. Ionic will be in a future podcast. The enthalpy change required to break a particular bond in a mole of a gaseous molecule is called the bond energy. And you'll see there's a table of bond energies here on the right out of your textbook. If you were to break hydrogen into two hydrogen radicals, you would end up with a requirement of 436.4 kilojoules. Chlorine, HCl, you see they all have sort of different values. Now, oxygen is a double bond, and you'll notice that that's a little bit higher value than the single bond. And in the case of nitrogen, where it's breaking a triple bond, it's even higher. And so in general, a single bond is less energy than a double is less energy than a triple. And so triple bonds are high energy bonds. Now, there are bond energy changes, and they somehow relate to the enthalpy changes in reactions that you did back in Chapter 6. Imagine a reaction proceeding by breaking all the bonds in the reactants and then using all those gaseous atoms to form all of the bonds in the products. That's the kind of calculation that we're about to do. The total energy in minus the total energy release would give us the delta H for that reaction. So that then if you took a sum of the bond energies of the reactants and subtracted the sum of the bond energy of the products, you should have delta H. And indeed, if you have an exothermic reaction or an endothermic reaction, the schematic looks like this. A, where the product molecules have more energy than the reactant molecules, you are endothermic. And indeed, in the second example, further to the right, the reactant molecules have more energy than the products, and so you have an exothermic reaction. Here are two examples of reactions that we could do the calculations for. The hydrogen and the chlorine make the two HCl's. Notice you're going to break an H to H bond and a Cl to Cl bond, and you'll make two H to Cl's. In the case of hydrogen reacting with oxygen, you have two H to H bonds, one O to O double bond to break, and then you reform to make the waters. Let's do a calculation using the bond energies to calculate the enthalpy change for the production of hydrogen fluoride. Again, sum of the bond energies of the reactants minus the sum of the bond energies of the products. So here we go. In the H to H, we're going to break 1, and so the energy change will be 436.4 kilojoules. We're going to break one F to F bond, and that's 156.9 kilojoules. And now let's do the formation. We're going to make two H to F's. They're 568.2 kilojoules apiece, so 1,136.4. And so the delta H for this reaction is going to be negative 543.1 kilojoules. And if you compare that to the delta H of formation of hydrogen fluoride, you'll find that it compares almost exactly.